Ladies and gentlemen, welcome to the first session of FIRE M about intake board meshing. Let me introduce myself. My name is Andreas Diemert. I'm analysis engineer for AVL FIRE and I'm working in the application fields of in-cylinder flow, general purpose CFD and industrial applications. In this session you will learn about the key features of the FIREM polymesher, what kind of preparatory work and surface repair is required. I will give you also an introduction to the FIREM polymesher, and in an online demo I will show you the meshing process of an intake board. Let me tell you now about the key features of the FIREM polymesher. It creates a fully polyhedral volume mesh. It allows a simple setup and a fast execution. It gives the possibility to create multiple hexahedron boundary layers, and it provides a basic and advanced user mode to set up the meshing process. And now we are coming to the preparatory work. FIREM allows the import of various CAD formats. As an example, we will use the STL format and we will perform a surface check and a repair of the surface. The quality requirements for the polymesher are a watertight surface, no duplicate faces or nodes, no self-intersections, no manifolds, and a consistent orientation of the surface patches. Furthermore, we will learn in this session how easy it is to generate edges, how to apply selections for inlet and outlet. We will also start the FIREM polymesher in basic mode. We define a target cell size, a boundary layer, and we specify the inlet and the outlet. And now it's time to switch to the online demo. We start FIREM by double-clicking on the icon on the simulation desktop. To start the surface preparation, we change to the CAD tab. We import the surface data, locate the STL file, and after importing, the STL file becomes visible in the 3D viewer. Changing visibility is also an option to get an overview about the geometry. In the next step, we will start the surface repair and run a complete check on the geometry. Quality criteria which do not pass the check are marked in red. Cracks, for example, can be fixed automatically. After fixing a certain criterion, it is recommended to run the complete check again. Double-clicking on the list shows you the location of the problem in the 3D viewer. Here exemplary demonstrated for a hole. To perform the auto-closing option, it is recommended to delete surrounding patches. This can be accomplished by putting them into a selection and cut them out. If required, repeat this procedure several times. And to close this hole, please proceed as follows. Find the open edges, we close the holes, and after closing we are merging them. Again, after this step, we run the complete check again. And last but not least, we correct the orientation, which means we flip the surface to get the correct orientation. Before continuing with the edge generation, it is recommended that we save our session. To generate the edges, we select Edge Detection from the ribbon. We change the angle threshold to 20. Press Detect Edges and the newly created edges are displayed in the viewer. Having a closer look to these edges, we can see some artifacts coming from the edge detection process. To delete these artifacts, we also put them into a selection. For that purpose, we create a polygon, drag it, and remove the elements from the edges. We repeat this procedure as long as we have some artifacts on the edge mesh. After cleaning the edges, we press Merge and Store, and the edges are now ready to set up the meshing process. We can close now the edge detection window and change to the automatic meshing tab. In order to create a little bit more space for the 3D viewer, we are reducing the section for the messages. We display also the surface so that it is visible again, and we start the poly mesher by selecting New Frame Poly. Surface and edge mesh are already pre-selected in the basic mode. We just have to press Analyze button. Since surface and edge mesh have passed the edge fitting check, we can start to input the parameters for the meshing. We specify a global cell size, we specify also the boundary layer thickness, and we specify the partitions for the inlet and the outlet. Partitions are topological regions created automatically by the tool. We finally save the setup and start the meshing process by selecting Create Poly. In this online demo, of course, we have shortened the meshing procedure. After the meshing procedure is finished, the mesh is automatically loaded into the viewer. As a last step, we perform a visual check to the mesh. This is accomplished by applying a cutting box and clipping into the geometry. By selecting Cut Geometry, we can also make the mesh visible in the cutting plane. The cutting plane can also move to other positions in the mesh. Details like a connecting edge can be easily displayed this way. To get back the full geometry, just switch off the cutting box. Ladies and gentlemen, we arrived at the end of our session. Let us summarize. FIREM offers the import of various native CAD formats. It provides also a robust surface repair workflow, and it gives the user a simple meshing approach. In case of questions, don't hesitate to contact us. Thank you very much for your attention.